Friends, today I'm going to talk about how to provide the right outcomes with your toric IOL to your patients and with respect to the biometry, right? So, how could you do a great biometry to provide the right outcomes to with the toric IOLs to your patients? Now, many decades back, Duke Elder gave us this chart wherein he showed us that a patient who has myopia or hypermetropia of zero point 0.5 diopters will land up with around somewhere around 6 by 9. But if your patient doesn't have myopia or hypermetropia, and if they have only a 0.75 diopter of astigmatism, then they land up with 6 by 9. So what it shows that after defocus, after myopia or hypermetropia, astigmatism remains a challenging factor for uncorrected, reduced uncorrected distance visual acuity, right? Now we know all that toric IOLs is made for regular astigmatism, right? You cannot use a toric IOL in irregular outcome in irregular astigmatism, and it may not give you the right outcomes. But the challenge is that how do you identify that the patient has a regular astigmatism? And this is the objective of my presentation today, because in biometry there are often times when you do not know whether the patient has a regular astigmatism or an irregular astigmatism, and I will talk about this in the subsequent slides. Now here you can see in the Zernike polynomials, it looks a little busy slide, but what I'm trying to show over here is that up to this part, the lower order aberrations, the astigmatism, you're correcting with toric IOLs, this lower order aberration. But the challenge is that in biometry is that sometimes may be an irregular astigmatism, an underlying irregular astigmatism that may also manifest itself as a lower order astigmatism when it is not. And if you cannot identify that there is an irregularity in astigmatism, there is probably a higher order aberration like coma, which is manifesting itself as a lower order astigmatism, then your patients may not get the right results, right? So if you have a topography, you can always do a topography. And here you have actually the bow tie pattern where you see with the rule astigmatism against the rule astigmatism or oblique astigmatism. And then in the topography, you can identify also if there is no bow tie, that means the patient may have an irregularity of astigmatism. But what if you do not have if you do not have topography, right? So how do you identify that the patient may still have an irregularity in astigmatism? So for example, you can see over here the patient in the right eye has 1.78 diopters of cylinder or astigmatism. But in the left eye, the patient has almost no cylinder or no astigmatism, right? So whenever the astigmatism difference between the two eyes is more than 1 diopter, then you have to be a little cautious. Ask your biometrician to do the biometry again. Or if you have an access to topography, do the topography, right? Because more than 1 diopter of astigmatism difference in two eyes is not that common, and it could be an indicator of some form of irregularity. It could be because of dry eye also, right? And here you can see several papers actually point out that the prevalence of dry eyes in the cataract population is quite high. Like in this case, I mean, the patients who did not have dry eyes was 44%, grade 0. But the other half actually had dry eyes, some form of dry eyes. And if you do not identify the dry eyes, that can manifest itself as an astigmatism. And you put a toric IOL, you may not get the right outcome, right? For example, in this case study, William Tratler shows us that this patient had a 1.55 diopter of astigmatism, right? And you would be tempted to put a toric IOL like a T4 model, right? Because a T4 model corrects around 1.5 diopter of astigmatism on the corneal plane. But when the dry eye was identified with this patient and was treated, this patient had no astigmatism then. So if the dry eye was not identified and a toric IOL was put, the T4 was implanted, then there would have been a total refractive surprise with this patient. Now, this is a paper that was published sometime back, a few years back, by Epitropoulos. And Epitropoulos showed us the impact of dry eye in keratometry measurements, because you rely on keratometry measurements to understand the astigmatism, right, part. So Epitropoulos, taking a value of 308 as the osmolarity value, showed us that there could be a difference of more than zero point 0.5 diopter in keratometry readings, right? So that is basically the impact of dry eyes on astigmatism. The other challenging factor is that when you put a drop before the keratometry, whether you do an optical biometry or you're doing an autokeratometry or you're doing a manual keratometry, if you're putting a drop on the cornea, what it does actually is that it makes the cornea more steeper. And when you make the cornea more steeper, you go for a flatter, a lower IUL power, and thereby you may run a risk of, hyperpixel price. In this case, for example, you can see that this patient has 49 diopter of astigmatism, which is quite high, which is more than the cutoff value. So, many doctors say that it's the cutoff is the 47 diopter. Anything between 41 to 47 is okay, but more than 47 diopters, that may be an indication of some irregularity, and you should do a topography. Luckily, in this case, the doctor had a pentacam, and you can see over here this patient had actually a totally irregular cornea. You may want to diagnose this as a keratoconus by seeing the elevation at the back or elevation at the front, but I'm not going into that. What I'm trying to say is that by seeing the sagittal curvature, by seeing the axial curvature here, you can identify that this patient actually has an irregular cornea. But what if you did not have this pentacam? What if you do not have a topography machine? Then these are the small subtle signs that you need to see to identify that this patient has an irregular astigmatism. Similar is this case here over here. This patient has 40 diopters of quite a flattish cornea, So this actually raised some suspicion, and when the surgeon did this topography, he found out that there was some amount of asymmetry between the inferior and the superior part, right? Now, one thing that we need to remember is that measurement is good as long as we can validate it. The measurement, we have to validate the measurement, right? Whether you'll be going with this axial length K readings and all, even before you look at the axial length of the K readings, you need to see how you can validate the data. And if you had an old IL Master 500, that gave you an SNR value, which is the signal to noise ratio. And signal to noise ratio, I think, is available also in the Tommy optical biometry machine. So too low a signal to noise ratio means, you may have to do the biometry again, or you have to look into the reason why the signal to noise ratio was so low. In certain cataracts, actually, the signal to noise ratio may be low, and so you may want to do the immersion biometry again, rather than depending just on the optical biometry. Now, in the ILMaster 700, there is a way of validating the data. Also, it doesn't give you the SNR value, but what it gives you is the foveal pit. So in this case, on the left side, you can see there's no visible foveal pit, and you cannot guarantee that the patient was fixating on the red light, right? So here on the right side, you can see that the foveal pit is visible, as well as the dots over here. The Purkinje's reflex are well centered around the pupil, so you can actually, probably be assured about the validity of this data. Now, the other way of validating the data is the measurements. Validating the measurements is the standard deviations, and all the machines will give you standard deviations, and you may not see this is the line where it is giving you the standard deviation for the right eye, and this is where it is giving you for the left eye. This is from the lens star, and to activate this, you need to go into the settings for the lens star. And you need to see the standard deviations over here. I have given you a standard deviations. What is the standard deviations that you need to follow? The standard deviation of the axial length, the standard deviation of the left eye and the right eyes, the standard deviation of the K readings. Remember, for every K reading that it gives, there are 5 readings that it takes in the background and gives you an average of that. So what is the standard deviation of those K readings? And it should be less than 0.2 diopters. Similarly, the standard deviation of the axis is also to be followed, and the axis is around 3.5 degrees. More than that, for example, in this case, the standard deviation is high, but that may be because of a very low astigmatism. But if you have a more than 1 diopter of astigmatism and the standard deviation is also very high, you may have to do the reading again and check for dry eyes or any form of irregularity. If you do not have an optical biometry machine, what you can do is, even with the autokeratometer in the background, it takes 10 readings over here. So in the background of the autokeratometer, it takes 10 readings, and it also will show you, if you go into this page, it will show you actually, what is the difference between each of these readings, right? And accordingly, you can actually, take the decision of whether you are going to rely on this data or not. Another important thing that you need to do is also check correlate wherever possible the subjective refraction with the corneal reading. For example, in this case, you have a against the rule astigmatism on the cornea, +2 at 180 degree. Is it matching with the subjective refraction of the patient? Wherever possible, wherever you get the subjective refraction of the patient. Sometimes I know that the patients may not carry glasses, or maybe the subjective refraction is too dense a cataract. So, but here you can see that the subjective refraction and the corneal readings are matching, right? The +2 at 180 degree, +2 at 180 degree also on the corneal reading. But sometimes, you have to take into account the lenticular astigmatism also. But what I am trying to drive home the point over here is that in terms of the axis difference between the corneal reading and the subjective refraction should not be more than 20 degrees, 15 to 20 degrees, right? So that's basically important also. And also, it should not show that the corneal reading is with the rule astigmatism and the subjective refraction is against the rule astigmatism. That actually doesn't make any sense over here. Again, here you have with the rule astigmatism on the cornea, and you also have with the rule astigmatism on the subjective refraction. So they are well correlating. Now, correlating the subjective refraction is important because, you cannot trust the optical biometry just to tell you whether there is irregularity of astigmatism or not. In fact, any optical biometry machine or any autokeratometry machine will not be able to tell you that there is an regularity of astigmatism. They always lie. They always give you the data on the hypothesis that the steep and the flat meridians are 90-degree away. So you have to be careful, and you have to follow the standard deviations and all those things that I talked to you. Two eye differences of astigmatism should be less than one diopter, correlate with the subjective refraction. A few points here before I close this talk is that choosing the right IOL platform is important. Why? Because recent research has suggested that NDAC can actually rotate the toric IOL. So there's no point in putting a toric IOL and within a year you have a lot of PCO. You do an EAG and the lens rotates, right? And also choose an IOL that has a proven kind of track record in high myopia patients, right? Some studies that actually indicate that this platform actually works in high myopia patients. The other thing is that rule out any major decentration in the eye, and this is important. Remember, I started by saying that Zanaiki polynomials, when you are measuring with biometry lower order aberration, but there are sometimes higher order aberrations that can actually mix up, and it can. And if the higher order aberrations component is more than the lower order aberrations, and you put a toric IOL, you don't get a right outcome. So rule out any major decentration in the eye. If you have an optical biometry machines, they give you in terms of X and Y coordinates. If you want more understanding on that, you can write to me on the comment section. But you can also do a simple Hirschberg test, and by throwing that torchlight, on the cornea and see the reflexes. So you can rule out major decentrations in the eye, because recent studies like Waketh study is showing that decentration in the eye can actually lead to residual astigmatism, right? And higher the diopter of the IOL, power of the IOL, with similar decentrations, you have more amount of residual astigmatism. And the other thing is that do not rule out the posterior corneal astigmatism. Rely on a form on a toric calculator that actually helps you to account for the posterior corneal astigmatism if you have not measured it, or if you do not have a system of measuring it. So in the Hoya toric calculator, you can always keep the Abulafia Cock regression on if you do not have the measured posterior corneal values. The Alcon toric calculator, if you are checking the biometry, the Barrett one, it is automatically going to theoretically compensate for the posterior corneal astigmatism. And the last but not the least is something that I want to talk to you about the stromal hydration part. If you are vigorously, doing the stromal hydration, then it might lead to a small rotation. So you have to be a little careful when you are doing this stromal hydration, because that might lead to a little bit of lens rotation when you are doing. Is a lot of with force. You are doing a lot of the stromal hydration with force. So you can always follow my my quickguide.org. That's my blog where I write on providing right patient outcomes with toric IOLs, multifocal IOLs, monofocal IOLs, also on the biometry part. I invite you to visit my website, as well as keep following my channel in YouTube. Do subscribe to the channel. Thank you very much.